Hey guys, welcome back. So today we're working on this 3600 watt Craftsman generator. Powering it is a 7-horse Briggs & Stratton engine, and this is one of the rare ones that has the elusive oil sensor. So this kind of dates this machine. You know, Briggs stopped putting this on in 2006. So I double checked the date code on the valve cover, and that confirmed that this machine was actually built in 2004. So this machine, it is 20 years old. Unfortunately, that's really all I know about it because someone threw this away. My friend Jason recently dropped off 2 truckloads of small engine equipment that was all discarded, and this was one of those items. You know, that said though, I don't think it should have been thrown away. You know, I have pulled the engine over, the engine rotates, although it squeaks, and we do have compression. So the engine theoretically should run, assuming we have spark, fuel, and timing. And this generator is actually a very reliable one. I've only seen one of these fail once. So I would say there is a very good chance that the engine will run and the generator will make power. That said though, it must have been thrown away for a reason. And I'm thinking it's likely a fuel problem. You know, the choke is on, the ignition's on, and unfortunately, the fuel valve is also on. So someone, I would say, tried starting it before they threw it out. And the tank, well, it's not empty. And the fuel, I wouldn't say is very good either. You know, it doesn't smell fresh. It smells a little bad. And there is some rust as well. So likely there is also water in there. So I'd say at a minimum, we're going to have to go through the fuel system. So let me get you set up a little bit better. We'll start by checking the basics, and hopefully by the end of this video, get this machine up and running again. So first things first, let's check the oil. That's how these engines commonly fail, at least the newer ones that don't have the oil sensor. You know, in this case, the engine rotates and we do have oil. It probably needs to be changed, but let's get the engine running first and make sure we have a viable machine. So before we dig into the fuel system, let's just check, make sure we have spark. And actually I can see the bushing for the fuel tank, it is damaged, so that is going to have to be replaced. That is a common maintenance item on these plastic tanks, and that is on there. It's kind of an awkward space with the fuel line and the fuel valve both in the way. I want to be careful not to hit that fuel valve. We might have 3 gallons of old fuel dumping on the ground. And yeah, that boot is really stuck. So it makes me wonder if this might be the original plug. And maybe the first time this has ever been unplugged. There we go. All right, keep an eye on the tester. Now, technically, this could start. The choke is on, the fuel's on. So let's pull it, see if we at least have spark. Okay, good. We've got spark. Well, at least we have an air filter, but I wouldn't say it's in great shape. Also, likely original. So we'll get that out of the way for now. And I was tempted to try to put fuel down directly in the cylinder, but given the really tight clearance, I don't think that's going to work. So I'm going to spray a little bit of starting fluid in there. I'm going to get a light connected. We'll pull it over, see if this thing comes to life, and if the generator makes power. I've got a light plugged in and turned on. Now we may not see it illuminate. You know, the engine does have to get up to speed, so we might need to try this a few times. You know, another good check too is just to make sure the throttle plate is not stuck, just in case the carburetor takes over. You know, the resting position, it is wide open throttle, and you don't want to have that throttle plate stuck, or you might make quick work of an otherwise good engine. So let's give it a pull and see what we get. Well, we didn't see the light turn on, but the engine, it did sound good. There was also a lot of debris flying out, so likely we have a critter or had a critter in the blower housing, so we are going to have to clean that out. But before we do that, let's just try it again. I'll feed it a little bit more fuel, see if we can get the engine up to speed, and hopefully we see that light turn on. There we go. That's all I needed to see. The generator, it makes power. So, you know, really, we're just dealing with a fuel problem. And this carburetor, it is not attempting to run this engine. So, you know, I think that is the next move. You know, we need to get the carburetor off and see if we can get it cleaned up. So we'll start there. And while we're at it, I think we'll just keep going. We'll get the blower housing off and clean up the mess that the critter made. Don't like that. I'm not even going to try to get this fuel line off. It is petrified, and the last thing I want to do is pull that out of the bottom of the tank. So we will just replace it, although I should probably shut the valve off before I cut it. I don't think this carb's ever been off. All these bolts are super tight, although that might be the wrong word for it. There's just a lot of corrosion on the threads, making it hard to turn out. Yeah, that one does not feel good. This is the low oil module. This is what shuts the engine down. The switch inside the engine is just what triggers this module to shut it down. It actually ensures a clean shutdown, whereas the switch, you know, it could intermittently detect a low oil condition, but unless it's kind of a steady low oil for a few seconds, you know, you don't want the engine just shutting down for a second and then resuming. So when it starts to shut down, this ensures that it shuts down completely. Okay. Not terrible. And not too bad. I think a lot of it got blown out, but you can see we do have some blocked fins. It looks like maybe a mud dauber nest and some more debris kind of up in there. So with an air-cooled engine, you have to have these passages clear for the fan to blow the cool air across the head. Otherwise, you're going to overheat the engine and cause permanent damage. So let's clean this out real quick, and then we can shift gears to that carburetor. Before going any further, let's get the fuel out of the tank and just see what we're dealing with here. I think that's all water. Anyway, I think you get the idea. There is still more fuel in the tank, so we need to get that out, but I'm not going to bore you with that. The first 2 bottles that came out were pretty much 100% water, so that's 4 liters of water right there. And it wasn't until the 3rd bottle that we made the transition to fuel. And the last bottle is mostly fuel. So as bad as this fuel looks, it can be poured off, leaving the water in the bottle and mixed with good fuel and likely burned. I guess the question is, how long does something like this need to sit outside to get this much water in the tank? The cap, it is damaged, but it's a fairly small hole. So, raindrops definitely were hitting that, but I'd say it took quite some time to accumulate that much water in the system. So what do you suppose the odds are that this carb can be cleaned up and used again? And judging by how really difficult it is to get this bolt out of the bottom, I'm thinking it's going to be rusted up pretty bad. I think I'm going to use the impact for that. Interesting. It's like a white paste. Kind of looks like baking soda. The bowl, though, not rusted, so that is surprising. Needle, I think, is stuck, and so is the pin holding that float in. Let me see if I can get that out. So it's stuck in there pretty good. A few people mentioned in the comments that a center punch will get this out. And yeah, it did move a little. Yeah, I'm not sure it really moved a whole lot. Oh, we got it. And that needle is stuck in there pretty solid. So I'm going to get the remains of the fuel line off. I'm going to run some WD-40 kind of through the areas where the fuel normally goes. Or actually, let's try some PB Blaster. And no, that is stuck solid. So I think for now, I'm going to let this soak for a while in the ultrasonic. You know, see if we can't get some of this white powdery goo out of here. And we'll try this again. I'm going to put an extra heavy dose of the Simple Green Pro HD in. You know, usually 5 or 10 minutes is all a carb needs to clean up. This one, I think it's going to need quite a bit more. And even if the needle does free up, likely the seat isn't going to seal very well. But let's deal with one problem at a time. Yeah, I let this carb soak for about 15 minutes. And, you know, although it is cleaning up, you know, that needle is still stuck in there pretty good. And when looking under the float, there is a fair amount of corrosion. So although I think I could get this carb to run again, you know, I don't think this one is a good rebuild candidate. You know, even the main jet, not looking the greatest. So I did dig around in my parts bin, and I came up with this. This is a clone carb. You know, I'm not sure exactly which model Briggs it's meant for, but from comparing the two, they do look the same. You know, I measured the throat on each side, and the measurements are the same. So I'm thinking we should at least give this one a try. Now, this one, I already did steal parts from at one point. You know, the throttle shaft was removed. The throttle plate was removed. And I think we are missing a few other pieces. So, you know, I'm going to look around. I might have some of those parts. Otherwise, you know, likely we can move a few parts over from here, you know, to make that one complete. And we can give this one a try. So this clone carb, it was in this bag. And actually, there is a throttle plate in there. So I don't think it would take much to reattach it. But now that I'm looking at it more closely, I think I know why it was in the parts bin. This bowl nut, you know, it looks like it pulled out the threads. And when looking at the bottom here, where it threads into, there is a crack. So this carb, unfortunately, it is just a parts carb. Well, I think we have a third option here. This one is actually an OEM Briggs carb. You know, the throat of the carb is the same, and so is the throttle plate configuration as far as the way it opens and where the governor linkage attaches. So I think we could use this carb. That said, though, it's not a slam dunk. We are missing the choke lever, so we're going to have to move this over from the carb that was on the machine originally. You know, a few other differences too is that this one is set up with what looks like a primer for a snowblower. So that I think we need to cap off. Also, the fuel inlet on this one is on the right, whereas the original is on the left. You know, I already test fit this, and I don't think it's going to matter that it's on the other side. It actually might work out, you know, a little bit better. You know, as far as the jetting goes, I don't know if the jetting is the same, but likely we can clean this one up and use it if it ends up running too rich. You know, as far as the internals go, it's all there. The interesting thing, though, is that this looks a lot more internally like a Honda clone, or actually not a Honda, but a Mikuni clone. Even the bowl. Mikunis have a little screw right there to drain. So I wonder, let me try a Mikuni bowl, because I would actually prefer to have a drain on here. So this is the bowl I was thinking of right here. You can see the design, it's very similar, but the diameter, not the same. So we're going to have to stick with the one that came with this. Now the carb itself, it looks actually brand new. You know, I don't see any signs that this has ever been used. So I'm thinking, you know, let's just bolt it on as is. And of course we'll add the missing choke and we'll cap that primer. And I think, you know, this should run the engine. Question is, how well? It seems a little high. Let's double check that. Nope, that's how it was. And a little vacuum cap like this should take care of that problem. So I'm going to bolt this on. I'm going to leave the airbox off for now. Let's just test it as is and see if this is going to work out. It's taking quite a bit of fuel, so I'm not sure if that needle and seat are working. Nope. We're flooding over. Well, let's try it anyway, real quick. Well, surprisingly, this carburetor just ran the engine perfectly. So if we can sort out the issue with the needle and seat, I think we'll be good to go. This was also a good test because I found another problem. I was happy with how things were running, decided to shut it down, and discovered that this switch was physically stuck. I could not click it to the off position, so I ended up pushing it with quite a bit of force and finally got it to click off, except the engine did not shut down. So either the kill wire is not connected anymore to that ignition coil, or maybe we have an issue with the switch or some other wiring. So we do need to dig into that as well. Starting at this time too reminded me we do need to replace that rope. And as far as the smoke goes, I don't think it's actually smoke. I think it's just soot and carbon kind of blowing out of that exhaust. So, if we run this a little bit longer, I think that should clear on its own. So let's get the carb off. We'll get that squared away, and then I think I want to move on next to the problems with the ignition system. I was just taking a quick look at the ignition system. There are 3 wires on this switch. The red one, which you can just see right there, that is the ground wire. The white comes from the oil module, and those both look to be connected to the switch. But there should be a black one, which runs to the coil, and that's ultimately what kills spark. And I can see that we do have a black right there, but it's not actually connected to the switch. It looks like the wire pulled out. So that is why the engine didn't shut down. But just as a quick double check, I'm going to start the engine again. I already did refuel it a bit, so we'll get it going, and then we'll just touch this wire to a bare piece of metal. And if it's connected properly down at the coil, that should shut the engine down. Looks like the carb fixed itself. All right, things are looking pretty good. This wire, it is still connected properly down to the ignition coil. So all we need to do is connect this back to the switch, and theoretically, that issue should be sorted. As far as the carb flooding goes, I think that issue also kind of fixed itself, which isn't that uncommon. When you have a carb apart and put it back together, sometimes the alignment isn't quite right, and that needle doesn't seal the first couple times. So we'll keep an eye on that, but I think this is likely going to be okay. I think it would be a lot easier if we could flip this upside down, but the tank's in the way. And the tank, it's going to have to come off anyway at some point, so let's get it out of the way now, and then we can access this with a little bit more ease. I don't think that did a whole lot for us. I still can't flip it over because the wires, they are too short. So there are tabs on the side to squeeze, and that should allow the switch to pull forward. And just take note, the red wire is on the on side, and the white wire from the oil module on the off side. And the center, that's the one that's supposed to go to the ignition coil, which obviously does not anymore. Let's make sure we get this right. The repaired wire goes right in the middle. That goes down to the ignition coil. The ground wire, which is the red, goes to the side that says on. And then the one that remains is the oil module. So we'll get this off to put some new rope on. And I do find it interesting that the paint on the starter recoil looks absolutely perfect. You know, it's subjected to the same elements as the blower housing, yet the blower housing looks the way that it does. So I might take the blower housing off again, or just sand it, get some more paint on it. Yeah, we can't actually get it off with the carb attached. So we need to loosen these bolts at the minimum to get a little more clearance. I was going to say the rope actually isn't too bad, but right here I can feel that it is mostly broken. So it only had a few pulls left, I would say, at best. So we'll just cut this old rope off. And the spring, it already is fully tensioned. So we will feed some new in, and we should be good. I've got plenty of extra cord on here, so I'm going to cut it a little bit shorter to make sure we have enough spring tension to pull it in. It's important to heat up the end here to keep it from fraying. Perfect. As far as the handle goes, I do have another from a machine that locked up due to a lack of oil. It's in much better condition, so I'm going to use that instead. So the airbox, it does have a bit of rust on it, so I'm going to let this soak overnight in the evaporust, which should clean it up pretty well. The last big eyesore on this machine is the exhaust. Now this plate used to be chrome, and I actually have another chrome plate that is in excellent condition. So all we have to do to install it is remove these 4 bolts. But these bolts, I know from experience, don't come out when they're this rusted. They're just too small, and if I mess with it, I'm just going to make the situation worse. So as much as it pains me, the exhaust, it functions just fine. So I am going to leave good enough alone. That's the fuel filter. So the valve that came out of the tank, technically we could probably reuse it. But these plastic valves I haven't had very good luck with, and I do have some metal ones which tend to work a bit better. So we'll get the new bushing installed first. And then we're going to need a little bit of oil or soap right around there to help push the new valve in. It's a day later. Cover's nice and dry. It came out pretty well. And the airbox, pretty much the same. That rust has disappeared. So I'm going to clean this out, dry it out, and we'll get this thing back together. So we'll get the filter back in. All right, stop your typing. We'll put a new one in. Just going to set this loosely back in place. The adjustment for the engine speed is under this cover. And we haven't verified if this is running at the right speed, so we will do that in a second. It looks like we're nice and dry. So I'm going to get the fuel line connected. And for that, I like using a little bit of WD-40. Makes the installation of the fuel line much easier. Let's start this one last time. I want to double check the engine speed. Now, this model, it does not have an AVR, so without a load, the voltage should be around 130 volts. And from the factory, these are usually set around 62.5 Hertz. So, I'm looking for something kind of in that ballpark. So we'll get the engine started and see where we're at. Okay, good. Both the voltage and the Hertz, they are where I was expecting them to be. So we are looking pretty good. So I think we can get this cover secured. We don't need to make any adjustments. But before I do that, let's get the oil changed. This machine, it is rated at 3,600 watts, so I am going to use the load bank to apply a 3,500 watt load. And then once you factor in the light, that brings us right up against the limit. So the plan is just to get the engine started. While it's warming up, we'll double check the outputs with the kilowatt. We'll see what the voltage and the Hertz are at, and we will double check the power quality as well. We'll double check those things as we bring the load on. Before I start it though, I do want to swap out the fuel cap. This one is damaged, and that's what led to all the water in the system. So I did buy a new one. Also, I swapped out the main jet. I compared the size of the original to the one that was on this carb, and the original was actually a few sizes larger. So, If we have any issues, we might have to swap back, but I think sticking with the original jetting likely will work to our favor. So far, so good. No problem starting the engine. Without a load, we are starting fairly low on the THD front. It's right around 7%, which isn't too bad. The sine wave doesn't look great, but that should clean up some under load. So let's bring on about a 1500 watt load to see how it does. So we're at 1500 watts. Engine speed is nice and stable. Engine sounds good. And the THD did not come up that much. We're at 7.3, 7.4%, so that is pretty good. And the sine wave, it did clean up a bit. So we'll give this a few minutes and assume everything goes well. We'll go for the max of 3600 watts. It's been a few minutes, no issues handling the 1500 watts. So let's take that load off and we'll replace it with 2000 watts. It's doing that just fine. How about 3000? Yep, but the engine speed dropped quite a bit, so I think we might be just about out of power. Let's try 3500. And yeah, that's making me nervous, so I think 3000 is the most we can pull from this machine. And actually something just happened. The engine speed recovered. We're still making power, but I'm wondering if one of the breakers tripped. And yeah, the kilowatt lost power, so one of the breakers did trip under a 3100 watt load, which it should not have done. There we go, you can hear the load went back on. So yeah, that breaker, I think it needs to be replaced. Well, things are going pretty well. We did make it up to 3500 watts, although the engine was clearly out of horsepower, so I did back it off to 3000 watts just because I didn't want to risk damaging the load bank. And surprisingly, at 3000 watts, we popped a circuit breaker. And that shouldn't have happened at 3500, never mind 3000 watts. So we do need to replace at least one of those breakers. Likely I'll do them both. So let's get this back inside and get that fixed up. To get this control panel off, we need to unplug the generator from this quick connect. And once that's out, there's just a nut in each corner, and this whole thing should pull out. think we upset a colony of something in there living over by the 240 output. So I wonder if those guys could be responsible for some of the issues here. Now it's really interesting. On the 30 amp plug, there is a hole here on the side and another one over here, which I guess those are factory. Yeah, we have one in each corner, but clearly their nest is inside that plug. So yeah, I don't think they're too happy about what I'm doing to their home. Anyway, these are the circuit breakers in question. They are rated at 15 amps. And I don't, actually, that says 20 amps. Which is even more interesting because we were tripping at below 15 amps. So yeah, let me get these out. Usually they're marked. I just want to make sure what the rating is, because I actually do have 20 amp breakers, but I don't have 15. So if these are 15, I'm going to have to order those up. It's interesting. There's no labeling on here, but you know, this generator, it's rated at a total of 30 amps. And I would think each one of these should be 15 amps. So I'm going to have to either scrounge up some or place an order. Yeah, it's a couple days later, and I did pick up 2 brand new 15 amp breakers to replace the ones that were in there. Now, these are not the OEM Briggs parts, but they are the same. You know, as far as the rating goes, these are 15 amp, and the dimensions are the same, which is important because of the way these mount. You know, they have to be the same length, and obviously the breaker needs to fit through the hole. So these should work just fine. I guess the only thing we have to keep in mind is which side is the line versus the load. So the line, that one faces this way, and we'll just double check here. Line, load. So we'll put that in like so, and we'll just secure it with the strap, plug everything in, and we'll be good to go. Yeah, that one's a little bit loose, so I'm going to tighten that up. Yeah, that's better. Yeah, a little loose. So these push connectors, they do loosen up. That's probably the one downside on these. But you want to make sure they're on there secure. Okay, good. So let's take a quick look at the circuit breaker internally to see if we can figure out, why it's tripping. Looks like there's only 3 rivets holding it together. So if we drill those out, I think we'll be able to open this up. And we're in. So the back cover just fell off. And yeah, you can see maybe a bit of corrosion in there. But it doesn't look terrible. Anyway, the way these work, these are actually a thermal circuit breaker. So this piece of metal here, it is a bimetallic strip. And as current flows through, it gets hot. When it gets hot, the metal deforms and kind of bends out of the way. And when that happens, there's nothing holding this from popping out. So the spring pushes it out, and it actually puts a piece of plastic between the contacts. So even when it cools down, it won't make a circuit again until you reset it. So let's put this in the vise. We'll apply a little bit of heat and see it in action. Huh. And there it goes. So the contact is actually on that side. And usually what happens is a little corrosion forms there. It becomes high resistance. So this falsely trips because it's creating more heat than it should. It's not because there's more current. There's just more heat. So you can see it actually went back, but there is a piece of plastic there. So we have to push this down to reset it. Now the contacts are contacting until it gets hot again. So yeah, actually that should have popped the spring up. So yeah, we could have other issues here, but I think it's just because I took it apart. Things aren't aligning quite right. Anyway, you get the idea. It's a very simple device and pretty effective. I've got everything connected back the way that it was. So, last time we did test the power quality and the output at no load and half load. So I'm not going to do that again. I'm just going to get it started. We'll let it warm up. I'll bring up the load to half, give it a few minutes, and then, we'll go for the max again of 3,500 watts on the load bank and likely back it off to 3,000 and just double check the power quality at full load. been a few minutes at 1500 watts and everything is running fine. So let's bring up the load. Let's swap 1000 for a 2000. So now we're at 2500 watts. The Hertz are at 61. Things are looking pretty good. So let's bring it up a little more. We'll swap a 500 for 1000. So we're now pulling 3000 watts. We're holding at 60 Hertz. The voltage looks pretty good as well. And the THD, not too bad. 10.7% THD. And the sine wave looks fairly unchanged from a half load. So I'm going to give this a minute and then we'll go for the max at 3500 watts. And no issues at 3000 watts. So let's bring it up to 35 and 36 once you factor in that light, which is the max load this can do. And it's doing it. We're holding at just above 59 Hertz. THD is 11.8%. The sine wave looks about the same. So I'm going to take the load off and we'll let this cool down. Well guys, I think that's pretty much it. You know, this machine was saved from the trash. Why it was there in the first place, I'm not sure. You know, the engine was good, the generator was good. Yeah, it needed a bit of TLC, but nothing too much. You know, at the end of the day, this is back up and running again, pulling its rated load of 3600 watts. So, I hope this video helps someone. Thanks for watching.